A racing bicycle, also known as a road bike, is a bicycle designed for competitive road cycling, a sport governed by according to the rules of the Union Cycliste Internationale. The UCI rules were altered in 1934 to exclude recumbent bicycles. The most important characteristics about a racing bicycle are its weight and stiffness, which determine the efficiency at which the power from a rider's pedal strokes can be transferred to the drivetrain and subsequently to its wheels. To this effect, racing bicycles may sacrifice comfort for speed. The drop handlebars are positioned lower than the saddle in order to put the rider in a more aerodynamic posture. The front and back wheels are close together so the bicycle has quick handling. The derailleur gear ratios are closely spaced so that the rider can pedal at their optimum cadence. Other racing bicycles, especially those used in time trialing, prioritize aerodynamics over comfort. Distinction between racing bicycles and others: bicycles for racing on velodromes are track bicycles. Bicycles for racing off-road are mountain bicycles, cyclocross bicycles or cycle speedway bicycles. Bicycles that race according to the rules of the International Human-Powered Vehicle Association include faired recumbent bicycles which, on flat ground, are the fastest bicycles in the world. Recumbents were excluded from the UCI definition of a bicycle on April 1, 1934. Time trial bicycles are a subset of racing bicycles that are designed for time trial events. The UCI rules for these bikes are slightly less prescriptive than those for mass-start road races. Triathlon bicycles are governed by International Triathlon Union rules, which allow more recent technological developments than do the UCI rules. Frame: the frame of a racing bicycle must, according to the UCI regulations, be constructed using a main triangle with three straight tubular shapes: the top tube, down tube, and seat tube. These three tubes, and other parts of the frame, need not be cylindrical, however, and many racing bicycles feature frames that use alternative shapes. Traditionally, the top tube of a racing bicycle is close to parallel with the ground when the bicycle is in its normal upright position. Some racing bicycles, however, have a top tube that slopes down towards the rear of the bicycle. The compact frame geometry was popularized by Giant. Frame manufacturers are free to use any material they choose in the frame. For most of the history of road racing, bicycle frames were constructed from steel tubing, and aluminium and titanium alloys were also used successfully in racing bicycles. Racing bicycles in these three materials are still commercially available and are still used by some amateur racing cyclists or in vintage racing classes. However, virtually all professional road racing cyclists now use frames constructed from various carbon fiber composite materials, and a typical modern carbon fiber frame weighs less than 1 kilogram. Particularly since the introduction of carbon fiber frames, the shape of the tubes that make up the frame has increasingly diverged from the traditional cylinder, either to modify the ride characteristics of the bicycle, reduce weight, or simply achieve styling differentiation. However, a recent trend in road racing bicycle frame design is tubing claimed to reduce aerodynamic drag, adopting many design features from time trial bicycles. While many professional riders use such bicycles, as of 2012 they have not been universally adopted in the professional peloton. Such frames are typically slightly heavier than comparably priced frames without aerodynamic shaping, and reviews of such bicycles have indicated that ride and handling characteristics of many have been inferior to more conventional bicycles. Racing wheels and tires: most road racing bicycles use 700c bicycle wheels with matching 25 mm wide tires. The wheels greatly affect the performance of a racing bike. The rim of the wheel can be shaped for greater aerodynamic efficiency, making a triangular cross-section to form a teardrop with the tire. The hill climbs, however, energy losses due to the higher weight of most aerodynamic rims are greater than the aerodynamic drag reduction that they offer, so a traditional lighter box-sectioned rim is often used to make it go faster. Wheel moment of inertia is a controversial subject. In this article, Wheel Theory, the author does some calculations on wheel effects. Moment of inertia changes result in a decrease in watts of between 0.004 and 0.022%, while lower mass provided between 0.2 and 0.46%, and better aerodynamics provided between 6 and 1.8% decrease in power. Therefore, wheel moment of inertia effects are neither noticeable nor important. At the same time, a product launched in 2008 to dynamically alter the rotating inertia of bicycle wheels claims to have outperformed the standard, equivalent wheel by 5.6 seconds per mile. For aerodynamics and rotating weight, it is generally better to reduce the number of spokes in the wheel. For high-end wheel sets, the spokes can be shaped to have a bladed cross-section, further reducing wind resistance. The most common material for a wheel rim is aluminum alloy, with molded carbon fiber rims being a popular choice for pro-level racers and enthusiasts. Carbon fiber rims are lighter than the same shape in aluminium, allowing riders to choose deeper, more aerodynamic rims without an unacceptable weight penalty. Race-grade wheel sets are very expensive and often fragile. Riders who race often choose to own at least 2 pairs of wheels, a heavier, more durable, and cheaper wheel set for training, and a lighter, more aerodynamic wheel set for racing. Racers with sufficient resources may have multiple racing wheel sets to choose from depending on the course and weather conditions. Deeper rims lose their aerodynamic advantage, and are hard to control, in high crosswinds, and on mountainous courses the lightest possible wheel set may be preferred by some riders. To reduce both air resistance and rolling resistance on the road, tires are lightweight, narrow, and have a thin, smooth tread. They are inflated to a high pressure, typically around 8 bar. Track racing tires can be inflated up to circa 14 bar. Until recently, most racing bikes use tubular tires which have no beads. They are sewn around the tube and glued to the rim. These tires provide an advantage in weight, rolling resistance, grip and pinch flat protection, but their greatest advantage lies in the ability to use a very lightweight simple box section rim, rather than the U-shaped clincher rim. A U-shaped clincher rim must be made of relatively heavier gauge material to prevent the tire pressure from spreading the inherently weak U-shape and allowing the tire to come off the rim. Advances in tire technology, however, have seen the far more practical clincher tire close the gap. Some manufacturers create tubular clincher tires, where the tires are sewn around the tubes and have a bead, but there is some debate as to the effectiveness of a tubular clincher tire. Proponents believe that it has all the advantages of a tubular tire made to fit a clincher rim, but critics argue that the design includes disadvantages inherent to both systems. The rim weight is still high, the tire is more expensive than a standard clincher tire, and repairing a puncture on a tubular clincher is as inconvenient as it is with a standard tubular tire. However, a particular benefit of the tubular clincher design is that the risk of pinch flats is very low, yet it allows the use of the more popular clincher wheel. Racing components. Race bike components are collectively referred to as the group set. The quality of the group set determines how refined the bike feels, how much maintenance it requires, and contributes to the performance of the bike. The 3 major group set manufacturers of complete group sets for racing bicycles are Shimano, SRAM, and Campagnolo. Some companies only produce specific components of the group set, such as full speed ahead. The companies have different design strategies, and some cyclists have great brand loyalty for one or the other. In the early 1990s, Shimano introduced dual control with a system called Shimano Total Integration. STI is characterized by its combined brake and shift levers, or brifters. Previously, the shifters were mounted on the stem, handlebar ends or the down tube of the frame. Dual control addressed the problem of having to reposition a hand to change gears. STI was followed by the competing Campagnolo Saxerga lever. SRAM uses a technology known as double tap for their integrated shifter brake lever. Other than this, the general design of a racing bicycle has changed little since the development of derailleurs. The road group set levels that these companies offer are as follows, from highest to lowest level. The number in the brackets indicates the number of cogs on the freewheel. Shimano, Dura-Ace Di2 Dura-Ace, Ultegra, 105, Tigra, SORA, Claris, 8s, Tourneo 70, 7s. Campagnolo, Super Record, Record, Chorus, Athena, Centaur, Velos, Mirage, Xenon. SRAM, Red, Force, Rival, Apex, Tens. In the mid-1990s Mavic, known for their wheel sets, introduced an electronic shifting system which was pioneered in the Tour de France by American Greg LeMond and later on by Briton Chris Boardman, who liked the fact that the system allowed him to shift from his aerobars and his brake levers. The system did not catch on due to technological hurdles. In early March 2006, some pro riders were seen riding with Shimano electronic shifting droop sets. Further testing in the pro ranks continued during the next 2 years. In late 2009, Shimano released their electronically shifted Dura-Ace D2 group set, consisting of battery-powered, servo-actuated front and rear derailleurs controlled by electronic bar end or brake lever integrated shifting paddles. Other components such as the crankset and bracket are carryovers from the standard Dura-Ace 7900 group. Recently in 2010, Campagnolo officially announced the finalization of their yet-to-be-named electronic shifting group set. Unveiled as part of the new Famolo Dogma Gyro Derailleur road bike, the new electronic group set appears to be similar in structure to Shimano's Dura-Ace D2 group set in that it combines existing top-of-the-line 11-speed super record parts such as the crankset and bracket with new battery-powered, servo-actuated front and rear derailleurs controlled wirelessly by an electronic eco-power-styled brake lever shifter. No specific details about the operation, performance or pricing of the group set have been released, but Campagnolo did announce that the Spanish Movistar cycling team will be the first professional team to use their electronic gear system in 2011. Carbon fiber has also become more popular for components. Shimano, Campagnolo and SRAM have introduced carbon fiber for their high-end shifters and brake levers, cranks, and parts of their derailleurs. Carbon fiber stems, handlebars, shoe soles, forks and seat posts are also more commonplace, including integrated stem handlebar combinations. The advantages of carbon fiber are low weight as well as increased vibration damping leading to a more comfortable ride. Other uses: for recreational road cycling, the racing-style bicycles with drop handlebars used to be the norm in the 80s, along with the touring bicycle. These designs, called road bikes, or colloquially, roadies, or racing bikes, have become less popular in recent years. The mountain bike geometry, with its straight handlebars and upright sitting position, have moved into the high-performance spaces, and high production volumes have brought down costs significantly. Owing to the lower air resistance and better body stance for pushing, road bicycles tend to be more efficient for use on smooth roads. Cyclocross bicycles, which are used for racing on off-road circuits, are closer to racing bikes than to mountain bikes. They have wider, treaded tires and cantilever brakes instead of caliper brakes but are still less efficient than racing bikes at higher speeds. UCI rules: the UCI rules currently specify that a racing bicycle have the following characteristics: be a vehicle with a front wheel steered by a handlebar and a rear wheel driven by a system comprising pedals and a chain by the legs moving in a circular movement, that the only points of support are the following: the feet on the pedals, the hands on the handlebars and the seat on the saddle. Wheels must be of equal diameter, between 70 cm and 55 cm, and must have minimum 12 spokes. Spokes can be round, flattened or oval, as far as no dimension of their sections exceeds 10 mm, maximum length 185 cm, maximum width 50 cm. The peak of the saddle must be at least 5 cm behind a vertical plane passing through the bottom bracket spindle. The saddle must be between 24 cm and 30 cm in length. The distance between the bottom bracket spindle and the ground must be between 24 cm and 30 cm. The distance between the vertical passing through the lower bracket spindle and the front wheel spindle must be between 54 cm and 65 cm. The distance between the vertical passing through the bottom bracket spindle and the rear wheel spindle must be between 35 cm and 50 cm. The maximum internal distance between the front fork ends is 10.5 cm, and of the rear stays 13.5 cm. Minimum mass 6.8 kg. frame must be built around a main triangle, constructed of tubular elements such that the form of each encloses a straight line. The maximum height of the frame elements shall be 8 cm and the minimum thickness 2.5 cm. The minimum thickness shall be reduced to 1 cm for the chain stays and the seat stays. The minimum thickness of the elements of the front fork shall be 1 cm. These may be straight or curved. The top tube may slope, provided that this element fits within a horizontal template defined by a maximum height of 16 cm and a minimum thickness of 2.5 cm. Note that the regulations regarding the dimensions of the bike are allowed exception, given that the rider can demonstrate a morphological need for the exception based on limb size or other factors. These rules effectively and purposely rule out recumbent bicycles, and have done so since 1934. Racing bicycles for non-competitive use. Racing bicycles are built for casual recreational use, often labeled as sportive bicycles or dropped bar fitness bikes. These have much in common with a competitive racing bicycle, but the frame geometry is relaxed to make the bicycle more comfortable over long distances, though less effective for short bursts of speed. They usually have a wider range of gear ratios and fewer high-tech racing features. See also: bicycle, bicycle frame, bicycle racing, list of cycling topics, road cycling. References. External links.